4 independent couples have one child. Let X, the random variable, be the number of children born with an illness among the 4 couples. This problem provides us with a probability distribution table. The X values range from 0 to 4. 0 is the situation where none of the children have the illness. That probability is 0.238, and it goes all the way up to 4. 4 would be all 4 of the children have the illness, and that corresponding probability is 0.001. This problem wants us to calculate the mean and the standard deviation. One way of doing this is to use formulas. There's a formula for the mean, which is the sum of x times p of x. So to use this formula, what you do is you multiply x times p of x for each situation and sum them together. That's the summation symbol. So this is going to be 0 times 0.238 plus 1 times 0.415. And then you just add up all those combinations. So this will be 2 times 0.272 plus 3 times 0.074 plus 4 times 0.001. And you can just plug that into the calculator and you'll get a value of 1.185. That is the mean of this situation, which makes sense if you think about it. The highest probability is 0.415, and that is an X value of 1. So the mean is the number of children we expect to see have the illness when I have 4 couples in front of me. And it's a little bit above 1, because if you look at 0.415, there's more probability below it than above it, so it's a little bit above 1. Now the standard deviation also has a formula. It is the square root, and then you have the summation symbol again. You take the x, but you square it, multiply by its corresponding probability, but then subtract the mean that you found up here squared from that summation. So doing this big long formula. All right, so we have 0 squared times 0.238 plus 1 squared times 0.415 plus 2 squared times 0.272 plus 3 squared times 0.074 plus 4 squared times 0.001. So that's the summation of all the x squares times p. And then you want to subtract the mean squared, which was found up here. That's 1.185. Don't forget to square it. If you plug that all into the calculator, you'll get a standard deviation of 0.8836. So for this problem, the mean is 1.185 and the standard deviation is 0.8836. Now there is a way to do this in the calculator. If you don't like using the formulas, what you could do is hit the stat button if you have a graphing calculator. It pulls up edit, push enter on edit, and you can put the lists in the calculator, 0, 1, 2, 3, 4. And then put the probabilities in the second list, L2, 0.238, 0.415, 0.272, 0.074, and 0.001. Once the lists are in the calculator, what you want to do is you want to hit the stat button again, but this time press the right arrow to go over to the calculations menu and push enter on one var stats. Now, if your calculator is like mine and it pastes it to the home screen, you're going to have to tell it 2 lists. You're going to hit second and the 1 button to pull up L1, and then push a comma, and then you need to tell it the frequency list, which in this case is our probability list. So then I'm going to hit second and the 2 button to pull up L2, and if you push enter, it gives you a bunch of statistics, and the top one is the mean. It matches up, 1.185, and the standard deviation sigma is also given 0.8836. So there's two ways of doing it. You can use the formulas or the calculator. There you go.